And looking at the companies you've been in, big companies like Netflix, LinkedIn, Uber, now DoorDash, based on your experience, what you saw, how often the model that is being built is truly, let's call it a big data model, a model that has to be distributed, at least the training has to be distributed, versus a model that's use biggerish data, but not really big data. You don't need a cluster to train it. Because I'm asking that because I remember, I remember those times of big data revolution, and I remember the transition, at least of my interest, more into machine learning, deep learning space. And I've been hearing that yes, like maybe big data is needed, but we don't, like, our models are not so big realistically. So looking at your experience and the teams you've worked with, what is the ratio? How often you really needed big data?
Yeah, that's a great question. What you observe is reflects what's in the industry. Not all ML models need large amount of volumes of data, which is very true. However, there are certain types of machine learning use cases that can benefit from large amount of data. I think we all know that. Specifically, for example, for Netflix, right? A major part of the business model able to survive and thrive is their recommendation engine. And that recommendation engine is fueled by a large amount of, all the user interaction viewing, movie viewing data and all the other stuff really help making their recommendation powerful and relevant and all that good stuff.
When it comes to these specific, for example, Netflix use cases, so did you see the pre-processing being as big, or also the actual features that you would feed to a model? Because naturally, yes, the pre-processing is huge, right? Because you need to combine all of the data sets, but do you feed all of that data into machine learning models as well?
Yeah, they do. And they come hand in hand, right? In order to generate all these large volume of features. And the freshness also plays in other important aspects of these kinds of machine learning use cases of recommendation. So the ability to process these data at high volume, and able to improve the freshness of the data using real-time streaming processing and such. For these kind of use cases, they play a pretty significant role in the model performance. A similar story at LinkedIn, right? So the job search and other search-related use cases, right? You have like millions and millions. I don't know. I forgot the number of users at LinkedIn now. It's quite large at this point. And then that's like very key to the feature set that will go into their job search or job recommendation system. And then you have a large number of jobs being posted on LinkedIn. And then all the companies and all the other aspects that come into the picture when making recommendations. Advertisement is another use case that can really benefit from large amount of volume as well. So not all use cases need large volume of data, but the ones that I see, especially from these three companies, are like recommendation, search, and ads.
Okay, so a question would be like, it's still like, you can imagine few scenarios roll out when it comes to big data and how you use that for training machine learning models. So one would be where you have a really big data set and then you're retraining the model, let's say weekly or daily, to achieve freshness in the actual model itself, or you can continuously fine-tune a deep learning model with new data coming in. So which one was the one that you observed mostly in this company?
Yeah, for these use cases, I think the freshness of the data it's pretty important. So the ability to successfully generate this feature or run these feature pipelines successfully on daily basis or probably wouldn't be weekly in these kind of use cases. Have to be at least daily. I know that for recommendation, I think Netflix, they started with like offline predictions and then put it in the cache. And then now they moving to the world where that cache is being refreshed like every 3 to 4 hours, for example. So it's depending on the use cases. Some use cases like this, the fresher the data or features, the better performance they can get out of them. But not all use cases need that. So it comes down to the kinds of use cases as well.
Talking about relatively frequently updated models, retrain models like daily or 3-4 hours a day, every 3-4 hours. I remember on this podcast we had a discussion around model monitoring, and there was a observation that if you are retraining your models so often, actual performance of model monitoring is not so important, because anyway in 2-3 hours you will have a new version of a model. I don't know how it works in practice, and you sound like the right guy to ask. What are your thoughts about it? Do you monitor performance of the models on production in such cases?
I have seen that when you do these kind of things, there's a couple of things. One is either you iterate your model architecture, or you retrain just with the same model architecture, but just fresher data, right? There's two separate scenarios. For the first scenario, you definitely want to monitor your models, because you don't know until you actually put in production, doing A/B testing and all that good stuff. So you want to detect problems as soon as possible. So for that part, I believe it's pretty critical to do that, to have proper monitoring in place. For the second case, like you mentioned, because you're not changing the model architecture, but just retrain. But then you have to think about, okay, the data pipeline could go wrong. Something could be messed up in the data itself. Hopefully there's data validation along your data feature generation pipelines and whatnot. But there's still that chance where certain values might have changed, right? It used to be XYZ, now is ABC, even though it's the same value and same type. So that could influence the model performance. So the same with that argument, I believe it's still very, very important to have the proper monitoring going on.
Makes sense. Plus, you quite likely, in such scenario of frequent retraining, want to use almost all data for retraining, right? Because you want to get the latest data to have this model as accurate as possible. So it is not so easy to really test it, especially in a recommender system setup after training.
And we know that data changes over time, evolve over time, right? Somebody changed a column from integer to flow or a string, whatever that is. And so, yeah, unless you freeze everything, then you probably don't need monitoring.